architecture and systems is causing that risk. Right? Architecture requires integration at scale. You said that, isn't it? Architecture requires integration at scale. Next year, I'll just say that rather than what I said. And in architecture, there are central organizing patterns. So would I say there are central organizing patterns, and how would I say that? Now, here's the things that Steve said are different in his world, and I'll challenge you and him to think about whether these really are different. You build one and you have to live with it.
Sometimes.
I don't know, as someone who spent most of my life on the International Space Station, I'm looking forward to building the next one. But you know, there are times when you build many things or something in engineering, and there are times when you build one of them. This type of architecture is, my way of saying it, intrusive on the environment. That is to say, it forces people to notice it and interact with it as they walk by a building. So, you know, who invented the laptop, and don't you think it's pervasive? And almost every one of you have one in front of you.
Yeah, but I'm not throwing up if I see one that I don't like to look at.
That's just because you're not so fussy. This whole form function, one leads the other leads one, you gotta think of one, there's the left brain and the right brain. I'll let you think about that. But I'll leave you with with something that I think really is true, that Steve said. One thing. This idea that soft is hard. That the softer things are, the squishier they are in some senses, the harder they are. The presence of constraints and the presence of rules and the presence of the laws of physics actually make a design problem easier, not harder, because it creates a much more narrow space in which the possible solution might occur. You know, and if you think of sort of engineering things, you know, probably at one end you get something, you know, just to use a sort of trivial example like a gear, where, you know, if you want to get rotation at this speed to rotation at this speed between two shafts, there's only about one or two real solutions at the conceptual level. You know, there's probably gears and belts, and maybe rolling plates, and that's about it. And you can give to a relatively junior engineer that problem, and they'll probably come up with the right answer. You know, and then in the middle there might be large, middle of our spectrum, there might be large electromechanical systems. And actually, one of the things that when we have the lecture from whoever talks about software, the first word of which, by the way, is soft, right, is that one of the things that makes software design hard is there's so many possible things you can do and so many possible ways you can do it. Right? Because there are no laws of physics that are in the way.
That's the laws of nature.
Yeah. Right. So you know, and then what Steve does is sort of pass that on the spectrum. Right? There, you know, it's all soft. Well, it's not all soft. There's a big soft part. And Steve has a big soft spot in his heart. It comes in business. So thank you for